So, dear students, this video has been specially designed to explain the various questions which have come in the examination for NEET exams. Let's see one by one, and especially for measurements chapter. So let's see what exactly are the questions that were asked in the exam. The very first question is, in an experiment, four quantities A, B, C and D are measured with error 1%, 2%, 3%, 4% respectively. Quantity P is calculated as follows. P is equal to A cube, that is A is present in P 3 times, B is present 2 times, C is present 1 time and D is present 1 time. Percentage error in P is. So it's a very simple question and very easy. Let's solve. It's a very simple thing. Let's see, do it like this. Percentage error in P will be equal to, now we have A cube, that means A is present 3 times. So we will write percentage error in P is equal to 3 times percentage error in A plus 2 times percentage error in B plus 1 time percentage error in C plus 1 time percentage error in D. And because we know all the values, we have to just substitute and get the final answer. So that should be equal to 3 into 1%, that is percentage error in A, plus 2 into 2%, which is percentage error in B, plus 1 into 3%, that is percentage error in C, and plus 1 into 4%. So I guess that will give you the answer as 3 plus 4 7 plus 3 10 plus 4 14. So the answer is 14%. So very easy question. Now let's move on to the question which was asked in 2014. So in 2014 we had a question like this. If force F, velocity V and time t are taken as the fundamental units, then the dimensions of mass are. That means, what way does mass depend upon F, V and T? Now whenever you have such a type of a question, you have to just write like this. That is, let M depend upon F, V and T. Like this we can write, let M be proportional to F, V and T. And because we do not know the powers, we'll call the powers of F as X, V as Y and T as Z. Now let us substitute the dimensions of the quantities on the left as well as on the right. So when we do that, we know that the dimension of mass is M1, L0, T0 proportional to, the dimension of force is M1, L1, T minus 2 and the power is X. The dimension of velocity is speed upon time, so it is L1, T minus 1 and the power is Y. And the last one is time. Time has dimension T1 and the power is Z. If we further solve, we'll get M1, L0, T0 as proportional to M power X, L power X, and here it is L power Y, so plus Y, and T power minus 2X minus Y plus Z. The standard way of doing the sum. Now if you see, the power of M on the left hand side is 1 and the power of M on the right hand side is X. So we can straight away equate and write X is equal to 1. Straight away X is equal to 1. Similarly, the power of L on the left hand side is 0 and the power of L on the right hand side is x plus y. So I can write x plus y is equal to 0, or I can write y is equal to minus x, and we know the value of x as 1, so y will be equal to minus 1. So we got y as well. Now the only thing is z we need to find. If we see the power of t on the left, it is 0, and the power of t on the right is minus 2x minus y plus z. So let's equate them as well. We'll get minus 2x minus y plus z is equal to 0. So we know the value of x as 1, we know the value of y as minus 1, plus z equal to 0. So that will give you minus 1 plus z equal to 0, or I can write z is equal to 1. So now we have the power of all. We have the power of x as 1, y as minus 1, and t as 1. So let's substitute in this equation, which I would like to call it as equation number 1. So when we substitute in equation 1, we'll get m will be proportional to f to the power 1, v to the power minus 1, and z is nothing but 1, so t to the power 1. So I think option number 4 correctly represents the given situation. So that should be the answer. Let's move on to the next question, that is AIPMT 2015, which was cancelled. But let's solve the question. The question which was asked, it's similar to what we did in the last question. If energy, velocity and time are chosen as fundamental quantities, the dimensional formula of surface tension will be. That means, what way does surface tension depend upon E, V and T? Let's start. The very first thing a student should know in this is the dimension of surface tension. So we should know that surface tension is nothing but force upon length. Force upon length. We know the dimension of force. The dimension of force is m1 L1 T minus 2 divided by length, that is L1. So the final answer turns out to be m1 L0 T minus 2. Now we can write, we'll denote surface tension as S. We will write let S depend upon means proportional to E, V and T. Because we don't know what way it depends upon E, V, T, we'll give the powers as X, Y and Z. And now this problem is similar to what we did in 2014. So now it's very simple. You need to just substitute the dimensions. The dimensions of surface tension, as we already obtained, is m1 L0 T minus 2 proportional to the dimension of energy is m1 L2 T minus 2 and the power is x. The velocity is L1 speed upon time, so L1 T minus 1 and the power is y. And for time we can write T1 and the power is z. Now if we further solve, we'll get m1 L0 T minus 2 will be proportional to m to the power x L to the power 2x plus y and t to the power minus 2x minus y plus z. So this is what we finally obtain. Now the next step is just equating the powers. So if we equate the powers, power of m on the left hand side is 1 and the power of m on the right hand side is x. So I can straight away write x is equal to 1. Similarly, the power of L on the left is 0 and the power of L on the right is 2x plus y. So if we equate the two, we will get 2x plus y equal to 0. Or I can write y is equal to minus 2x. But we know that the value of x is 1. So if I substitute here, I'll get y is equal to minus 2. So I got the value of y as well. Now let's equate the powers of t. The power of t on the right hand side is minus 2x minus y plus z, whereas the power of t on the left hand side is minus 2. Let us substitute the values of x and y. 2 into 1 minus minus 2 plus z is equal to minus 2. So I think this minus 2 plus 2 gets cancelled, and z finally turns out to be z is equal to minus 2. So I know the value of x, y as well as z. Let me substitute these values in equation number 1. When I do that, I will get s is proportional to e to the power 1 v to the power minus 2 and t to the power minus 2. And I think option number 1 matches with the given situation. So that's your answer. Let's move on to AIPMT next exam 2015 once again. This says that if the dimensions of critical velocity of a liquid, so we should know that Vc is nothing but velocity of a liquid flowing through a tube, are eta to the power x, rho to the power y, r to the power z, where eta, rho and r are coefficient of viscosity, density of liquid and radius of the tube, then the values of x, y, z are. So it's a very simple question, similar to what we did in the past, but then definitely we should know the coefficient of viscosity. Let's calculate the coefficient of viscosity, dimension of coefficient of viscosity. There is a formula in friction, in liquids. In fact, the viscous force on a spherical ball passing through a liquid is given by the formula, or passing through a medium is given by the formula F is equal to 6 pi eta RV. And from this we can get the dimension of eta first. Eta will be equal to F upon 6 pi RV. So that will be equal to, let's substitute the dimensions. Force is M1, L1, T minus 2. 6 pi is a dimensionless constant. Radius is L1 length and velocity is L1 T minus 1. So I think this L1 can be cancelled here. So final answer what you get is M1 L minus 1 and T minus 1. This is your answer for coefficient of viscosity. Now, according to the given question, Vc is equal to eta to the power x, rho to the power y and r to the power z. Substituting the dimensions, we will get velocity is nothing but, let's substitute the dimension. Velocity is nothing but L1 m0 L1 t minus 1. That will be equal to eta we already calculated. It is m1 L minus 1 and t minus 1 and the power is x. Density is nothing but mass upon volume. So I can write m1 and volume is L cube. So in the numerator it becomes L minus 3 raised to y, and r is nothing but radius. Radius is a length. So L1 z. So if you further solve, you'll get m0 L1 t minus 1 equal to m to the power x plus y, L to the power minus x minus 3y plus z, and t to the power minus x. Right? I think we have taken into account everything. Okay. Now, if we equate the power of t first, we'll come to know that the power of t on the left hand side is minus 1 and the power of t on the right hand side is minus x. So the very first thing which we can write is minus 1 is equal to minus x. So from this, x will be equal to 1. Second, we also know that x plus y is equal to 0. So I can write y is equal to minus x. So from this, y is equal to minus 1. And the last, if we see the power of L on the left hand side, it is 1, and on the right hand side it is minus x minus 3y plus z, and that should be equal to 1. We know that x is equal to 1, so minus 1 minus 3 into minus 1 plus z equal to 1. So this is minus 1 plus 3, that is minus 2. Yeah, so this is what we were talking about. This is minus 1 minus 3 into minus 1 plus z equal to 1. So this turns out to be minus 1, this is 2, right? Minus 1 plus 3, so that is 2. 2 plus z equal to 1. So z is equal to minus 1. So finally we got all the answers. X is equal to 1, y is equal to minus 1, and z is equal to minus 1. So the correct answer is C, right? Let's move on to NEET 2016 and let's see what was the question. So again, similar type of question, but definitely this is not easy. Planck's constant h, speed of light in vacuum c, and Newton's gravitational constant g are three fundamental constants. Which of the following combinations of these have dimension of length? So ultimately we have to see a combination of h, c and g such that the final answer should be equal to L. Let's see how we can do it. So the very first thing we'll do is, so ultimately the final answer is L, so we can write like this: let length, let L depend upon h, g and c. Now here we should know the dimension of h and g, only then we can do something. So let's get the dimension of h and g first. We'll do that. Okay, so let's see that. First I'll call this as, okay, we need to give the power also, so I'll call h raised to x, g raised to y and c raised to z, and here I will calculate the dimensions of h and all that. We know that the energy of a photon is given by the formula E is equal to h into f. So h will be equal to E upon f. The dimension of E is m1, energy is m1 L2 t minus 2, and frequency is 1 by time, so t minus 1. So finally that turns out to be m1 L2 t minus 1. This is the answer for dimension of Planck's constant. So we know the dimension of Planck's constant now. Similarly, we should know the dimension of g, which can be obtained by Newton's law of gravitation. F is equal to g m1 m2 by r square, and from this g will be equal to fr square upon m1 m2. So if you solve this, I think you will get the answer as m1 L1 t minus 2 into square of the distance, that is L2, upon m1 m2, that is m1 and one more m1, right? Their masses. So m1 m1 gets cancelled and the final answer turns out to be m minus 1 L3 and t minus 2. Now let's solve. So we know the dimension of all the quantities involved. Let us substitute the dimensions and I will call this equation as usual as equation number 1. Now the dimension of left hand side is m0 L1 T0, whereas the dimension of Planck's constant is m1 L2 t minus 1 and the power is x. For g it is m minus 1 L3 t minus 2 and the power is y. And for c it is c, speed of light, so length upon time, L1 t minus 1 raised to z. If you further solve, you will get m0 L1 T0 is proportional to m to the power x minus y L to the power 2x plus 3y plus z and t to the power minus x minus 2y minus z, right? Now as usual, let's equate. So the power of m on the left hand side is 0 and the power of m on the right hand side is x minus y. So when we equate, x minus y will be equal to 0, or I can write x is equal to y. So this is the first relation I get. Similarly, if I see the power of t on the left hand side, it is 0 and the power of t on the right hand side is minus x minus 2y minus z. So that is equal to 0. Now I can write y as x. So I'll get minus x minus 2x minus z equal to 0, or I think I will get z is equal to minus 3x, right? Now let's the last one, that is equating the power of L. The power of L on the right hand side is 2x plus 3y plus z, and on the left hand side it is 1. So if you solve this, we can write y as x and we can write z as minus 3x. So everything will go in x. So we'll get 2x plus 3x minus 3x equal to 1. So I think plus 3x minus 3x gets cancelled and you'll get x is equal to half. So if x is equal to half, then that implies y is also equal to half because x is equal to y. And z will be minus 3x. So z will be equal to minus 3 by 2. Now substitute the values on the top and you will get, that is, substitute the values in equation 1. You will get L is proportional to h to the power half, g to the power half, and c to the power minus 3 by 2. Or I can write L is proportional to hg the whole raised to half upon c the whole raised to 3 by 2, which can be further written as, or it can be written as proportional to root of, because we know raised to half is root, upon c raised to 3 by 2. So I think the option is option number A. This is the correct answer. Now let us move on to 2017 question, and this question is a bit tough. So let's see how we can solve. A physical quantity of dimensions of length that can be formed out of c, g and e is, and c is velocity of light, g is universal constant of gravitation, and e is the charge. Now if you see the option carefully, you will realize that in the option 3 things are always there: c, g and e square upon 4 pi epsilon naught, and this all should come together to give me the answer as length. This is because that is what is the question says. That means my length should depend upon c, g and e square upon 4 pi epsilon naught, right? So let me first think about that e square upon 4 pi epsilon naught. We know that the force between any two charges in the sense any two electrons, or a proton and an electron, is given as 1 upon 4 pi epsilon naught into e square upon d square, where d is the distance. So I can write e square upon 4 pi epsilon naught is equal to fd square, right? So f, we already know the dimension and this is square of distance. So if you substitute, you will get m1, L3 and t minus 2. This is what we will get, right? This is the dimension of this thing, e square upon 4 pi epsilon naught. Next, g, we already know the dimension. The dimension of g is m minus 1 L3 t minus 2, and c, we already know speed of light, and all these combinations should finally give you length. So my length depends upon c, g and e square upon 4 pi epsilon naught. So I will write, let L be proportional to e square upon 4 pi epsilon naught the whole raised to x. Let it also depend upon g, so g raised to y and c raised to z. This is what I will write. And now let's solve. Substituting the dimensions. On the left hand side we have only length, so the dimension of length can be written as m0 l1 t0 proportional to e square upon 4 pi epsilon naught. We already got the dimension as m1 l3 t minus 2 and the power is x. For g we know the dimension is m minus 1 l3 t minus 2 and power is y, and c is speed of light l1 t minus 1 and the power is z. Now let us further solve. m0 l1 t0 proportional to m to the power x minus y l to the power 3x plus 3y plus z and t to the power minus 2x minus 2y minus z. Now let's solve. First we will equate the power of m on both the sides. The power of m on the right hand side is x minus y and on the left hand side is 0. So from this I get x is equal to y. First thing. Now power of t on the right is minus 2x minus 2y minus z equal to 0, whereas on the left it is 0, so I equated that way. Now I know that y and x are same, so I will write minus 2x minus z is equal to 0. In fact I can write z is equal to minus 4x. Now the only thing which is left to be equated, that is that is L. The power of L on the right hand side is 3x plus 3y plus z and that is equal to 1. So from this I can write, substitute the values of x, y and z. I can write 3x as it is. I will write y as x and I can write z as minus 4x and that should be equal to 1. So I will get 2x equal to 1. So I will get x as equal to half. So the first thing I got is x is equal to half. Now if x is equal to half, then y is also equal to half. And z is equal to minus 4 into half. So z will be equal to minus 2. So I got the value of x, y and z. Now the only thing left is substituting in equation number 1. If I substitute in equation number 1, I will get L is proportional to e square upon 4 pi epsilon naught the whole raised to half, g the whole raised to half and c the whole raised to minus 2. If I rearrange the terms, I will get L is proportional to 1 by c square, then e square upon 4 pi epsilon naught and g the whole raised to half. And this is like option number. The option which corresponds to this is, I guess, option number D. So that should be the answer. The next question, which was asked in 2018. So let's see what is the question. A student measured the diameter of a small steel ball using a screw gauge of least count 0.001 centimeter. So we know the least count of the screw gauge directly given. The main scale reading is 5 mm and the 0 of circular scale division coincides with 25 divisions above the reference level. That means we know that the coinciding coinciding circular scale reading is nothing but 25. Screw gauge has a zero error of minus 0.004 centimeter. What is the correct diameter of the ball? I think this is one of the very easy question. I mean, this is very simple. There is a direct formula for doing it. Let's solve. So we can write like this. diameter. In fact, the formula is like this: final reading is equal to main scale reading plus coinciding circular scale division into least count minus zero error. So I'll just write down the final this formula for you. Final reading is equal to main scale reading plus coinciding circular scale division into least count minus zero error. This is a standard formula, right? So main scale reading is already given to us. It is 5 mm, which I would prefer to write 0.5 centimeter because the options are in centimeter. This is 25 and the least count is 0.001 centimeter minus 0.004 centimeter. So when you solve, you'll get 0.5 plus 0.025 plus 0.004, and the final answer is 0.529 centimeter. So very easy sum. This is the answer. And let's do the next sum, last sum on measurements, that was asked in 2019. So it was asked in 2019. I'll write here. This is NEET 2019, the latest, right? Let's see. And it's same as what was asked in NEET 2013. So let's see. In an experiment, the percentage of error occurred in the measurement of a physical quantity A, B, C and D are 1%, 2%, 3%, 4% respectively. Then the maximum percentage error in the measurement of x, where x is a square, b raised to half, c raised to 1 by 3 d cube will be. Let's solve straight away as we have done in this NEET 2013. Let's see. Percentage error in x is equal to 2 times percentage error in A plus half times percentage error in B plus 1 by 3 times percentage error in C plus 3 times percentage error in D. So let's substitute. We are given everything. 2 into 1% plus half into 2% plus 1 by 3 into 3% plus 3 into 4%. So this will be equal to 2 plus 1, 3, 4 and 12. So 4 and 12 will be 16%. So this is the answer. So thank you for watching the video. I'll be soon posting the next chapter of NEET. So keep watching. Thank you.